Hi, and welcome back. So now let's take a look at class attributes. So I just want to make very clear right now, I'm looking at classes. Classes are objects. I am not at this point looking at instances of classes. Everything I'm talking about here is directly related to the class object itself, right? So let's see how we can define attributes in a class. Again, I'm not talking about instance, I'm talking about class. So here we have this brand new type that we're creating called myClass. It's going to be an object. And now it will have two attributes, language and version. So this is how we can create and define values for attributes directly inside the class. We just do it that way. So remember, myClass is a class, but it is also an object of type. Now, in addition to whatever attributes Python automatically creates for us, like that done_the_name method, for example, that done_the_name attribute, right, that we saw before, we have other things as well. Now we have language and version as well, which are attributes of the class. Again, not the instance, of the class. And so the state is Python and 3.6, respectively. Now, how do we retrieve attribute values from objects? And this applies to objects in general, not just classes. This is just for objects. Since a class is an object, this works the same way. Well, there is a built-in function in Python called getAttribute, getAttr. And the way we use it is we call this function, we pass in the object symbol. Maybe, for example, myClass. So it could be the function name, for example, right? The symbol that we have for a function. Or maybe it's something else. And we'll see this really applies to any object. So getAttribute, and then we give it the attribute name. The attribute name is going to be a string. That's going to be the name that we want of the attribute that we want to retrieve. And then we can also have an optional default. So we'll see how those work. So in this case, myClass is an object and it has two attributes, language and version. So I can get the value for the language attribute. So you'll notice I pass in myClass, the symbol for the object, right? myClass, and then the string of the name of the property that I want. Property names, attribute names in Python are always strings, and they get treated as strings. So I do that, and I'll get the value back, Python, because that's its current state. Now, if I try and get the attribute that doesn't exist in the object, so in this case, myClass doesn't have an attribute called x. If I try and get that attribute, I will get an exception. Python will raise this attribute error exception. And this is where the default value comes in. If I want to get a default value if that attribute doesn't exist, I can do that by specifying this optional default value. And so in this case, Python will return the string NA because that's what I specified as the default. So this is pretty handy when we get to code where we want to get attributes and values for those attributes, but we don't want to create exceptions when the attribute doesn't exist. We want to return some default value. Maybe we want to return none, for example, right? Something like that. Now, that's the getAttribute function, but there's actually a shorthand way of doing it, which I'm sure you've seen before, and that's the dot notation. So we can say myClass dot language. This is equivalent to saying getAttribute myClass, comma, and then the string language, except we don't have to put the string quotes around this property name over here, this attribute name language. And so we'll get the string Python back. Now, it's important to note that with the dot notation, when you request an attribute that doesn't exist, we will get the attribute error exception, and there is no way to specify a default here, right? So you cannot have something that's equivalent to this third form of the getAttribute function using dot notation. So if you need to have a default, if the attribute doesn't exist, then you'll need to use the getAttribute, the getAttr function. Otherwise, we can just use the dot notation. It's a lot simpler. So how can we set attribute values in objects? Well, let's say that we have this object here, myClass, right? And it has these two attributes, language and version. Well, we can use the setAttribute function, the setAttr function. Again, it's a built-in function. It's very similar to the getAttribute. We pass in the symbol for the object. We pass in a string for the attribute name, and we pass in the value that we want to set that attribute to. So in this case, we could say setAttribute myClass version 3.7, right? We can also use the dot notation. So again, the dot notation is very handy. It makes code much cleaner, but it's equivalent. So this now has modified the state of my class. My class was mutated. And if we actually call get attribute or use the dot notation to get the value of version now on my class, you'll see that it is now 3.7. Again, we're modifying my class, this object. We're not talking about instances of my class. We're talking about the class itself, which is an object. So let's continue with setting attribute values in objects. Let's say we have this object here. And what happens if we try and call set attribute for an attribute that doesn't already exist in our object, in our class? Well, Python is a dynamic language. Things are not set in stone. So just because I don't have a particular attribute in this object at this point in time when this was compiled, it doesn't mean that later on as my code is running, I cannot add and remove attributes from that object. I can. We've seen that many times before. When we write, let's say, decorators, and we were looking at the decorator that allowed us to do generic single dispatch. Well, we had to add an attribute to a function, right? That was our decorated function. We were returning that with an extra attribute. Well, Python didn't have that attribute when it compiled the function. We added in later to that object. So the same thing happens with a class. It's no different. We can add attributes to our classes, to any object, practically, once it's already been created. Some of the built-ins, you can't do that. You can't do that with an integer, for example. But certainly our classes, we can. And that's because Python is dynamic. So we can use the set attribute on my class and pass it a new attribute name, x, and a value of 100. Or we can just use the dot notation. So my class didn't start off its life with the attribute x, but now that we've called either of these two pieces of code, now it has it. Now it has a new attribute named x, and if we call get attribute on my class for x, we will actually get 100 back. Or we can just use the dot notation. Now, where is that state stored? That's kind of an interesting question. Where is Python storing that state? Well, in a dictionary. Like most things in Python, everything uses dictionaries, right? It's ubiquitous to Python. Classes are no different. The state of a class is stored in a dictionary. So again, let's look at this example. We now have an attribute called dunderdict that Python provides for us. So that's one of the attributes that Python automatically provides, just like it provides the dunder name. We have the dunderdict. What does that return? Well, that actually gives us a mapping proxy. Now, a mapping proxy is not a dict type, but it is a dictionary. It is still a hash map. And basically, you can think of it as a read-only hash map. And in particular as well, it means that Python is now able to ensure that all the keys in this class, basically in here, are strings. So this is why I was saying all our attribute names are considered strings. And Python enforces that, makes sure that it's a string. You'll notice when we look at this mapping proxy and think of it just as a dictionary, we have language is the key, Python is the value. Version is the key, 3.6 is the value. That's this language and version that we defined over here. It is inside that dictionary. So we often call that dictionary the classes or the object's namespace. Now it's not directly mutable, right? We cannot mutate, we cannot add keys and values to this or modify the values for existing keys to this mapping proxy. It's a read-only kind of property. But we, of course, are able to modify the contents of this dictionary indirectly by using the set attribute function or the dot notation. So one of the things, as I mentioned, is that Python ensures that these keys are all strings. And that allows us to do some kind of speed ups that it can do by doing string interning, and then it doesn't have to do any quality comparison when it's trying to find a string in the dictionary. It just basically uses the identity operator because it's interned the string. And I talk about string interning in the very first part of this series. So mutating attributes. So let's say that we can modify the state or create a brand new attribute using the set attr function or the dot notation. So again, we're going to look at the same class. We can look at the dictionary currently. We'll see that it contains, amongst other things, it contains the language and the version. Now we can mutate my class. We can set the attribute x to be a value of 100. or we can just use the dot notation to do the same thing. That's now reflected in that namespace. If we call dict now on my class, you'll see that it contains x with a value of 100 now. So basically all the state of the class is stored in a dictionary. Now, can we delete attributes at runtime? And the answer is yes, right? So we can mutate, we can actually also remove. So usually we can, we'll see examples where we can't. So we can use the delete attribute function or the del adder function, and we just pass in the symbol and the string containing the attribute name. We can also use the delete keyword. If you think about it, we use the delete keyword often when we were deleting entries from a dictionary, for example. We'd say delete and then the key that we want to delete, right? So this is no different really here. Everything's stored in a dictionary. We can remove things from the dictionary. So we can either use this function or we can use the delete keyword. So again, if we start with this class, if we look at this dictionary mapping proxy, we can call the delete attribute function, or we can just say delete myClass.version. Just like we can say delete dictionary square bracket and then the key name. Here we just say delete the object dot and then the attribute that we want to delete. Same thing. Or we can use the delete attribute function. Now if we look at the mapping proxy, if we look at the namespace, you'll see that version is now gone from there. It will no longer be in that dictionary. Now, accessing the namespace directly, we have this DunderDict over here, so that's nice. We can take a look at what's contained in a class. That's actually very handy sometimes, especially when we're debugging and things like that. It's actually quite useful. So the dict attribute of a class returns a mapping proxy object. We can't modify it, but we can at least read it, right? And it works just like a dictionary does. So in order to get the value for language out of my class, we can use the dot notation. We can also use the getAttribute function, or we can actually do it this way as well. We can call DunderDict and then pass in language. That actually works. In this case, this works. Now, it is not common practice because not everything is stored in this dictionary. We'll see that later. So don't get into the habit of trying to get the value out of an attribute of an object by using this DunderDict. Use the getAttribute or use the dot notation. Don't use this because that doesn't always work. But it's interesting to note that it can work, and it's very useful sometimes for debugging if you just want to see what's contained in my dictionary for my object right now, in my state dictionary essentially, right? And you can get all kinds of interesting things coming back in there. Okay, so just be careful with that, and we'll come back to that later and see why and when it doesn't always work. All right, so let's switch to some coding and let's try all that out. Thanks for watching, and I'll see you in the next video.